In this section, in this video, I'm explaining some of the key points when I follow the instruction of this tutorial section, tutorial videos from Simplified Coding part 3, 4 and 5. I did all of them in one step because at the end, in step 5, it gives actually visual anything that can be viewed, can be seen. So therefore I come back. So what we have done, let me just quickly come to the new files that have been added to this stage. First of all, sorry, hmm. Okay, here are the changes starting from the main activity, the Java. So the whole implementation of this practically really simple paging, scrolling functionality is way overcomplicated. It's impossible and unbelievable that programmers today are expected to create so complex style of programming. It's really ludicrous and ridiculous what Google designed with this Android application. Let me just explain why I think so. So here is then the main. I simply comment out a call stack exchange and I created a new function init page recycle view. And here in this function, what it does, let me just open in the in Android Studio. Yes, this is the main. So what I am doing here, following the instruction from the tutorial mentioned above, that here's a recycle view, set the layout, linear layout manager, so far the regular stuff, and then I create an instance of a stack exchange item data source view model, and then instead of just creating with a new, we use here a quite fancy creator utility of the Google line, actually the class name, like so, view model class. So to me it's the first sign to me that it's absolutely overcomplicated. Why not just simply create a view model? Ugh. Now anyhow, and then came the next point for the page viewer, and then within this view model we created a page list, and then we are going to adapter with data. Submit last items, page list, exchange answers items. So this is quite okay. And then we set the adapter. So this is it. So let's have a look what the actual item adapter is doing. The item adapter is has a from the cycle view adapters that this page list adapter is going to handle its items either, so you don't have to bother with that. Uh, so for this we create a diff util which makes the comparison: are items the same, are contents the same. So anyhow, so this is one of like so may more or less it's okay. And then we just create the regular view holder, which is quite standard. And then the bind view holder. Here is a fancy but a bit how to say suspicious architectural wise thing that it happens that the onBind folder, actually this we use here the glide function to load the images from a URL into the image view, and then this is an image view in the view holder. So the reason I say it's not really okay from architecture perspective, that actually it's not really the job of the bind holder to set the contents of something within the view holder. So what I would do here is just I would create a function within the Stack Exchange view holders, and then rather than letting glide directly set the value. But this is really convenient. This is how it is implemented in this really primitive example: Stack Exchange view holder, and then again set the text. And yes, this is how it is done. So this item adapter is okay. And now comes the really messy, complex part. So to be able to get any data to work directly with the page adapter, first you need a data source which should be extended from from a couple. You have an option for extending it for a couple of data sources. Here in this example we use the page key data source uh, class, which we extend from, where the key is an integer. Actually this is the page number, and then the value are the items. So far so good. Okay, so this is the data source, and then it has three major loader functions. The first one is the load initial data. So this is just a regular retrofit HTTP call. And then when we have the data, this is all on response, then we simply call a callback which we received in this load initial. This is the callback function state stack in change answers dot load initial callback. This is the name, a type of the function, and this is the callback that we should call with the results. And then we define here a couple of data, and this load before again uses the callback function to feed the previous page. What is interesting that in this example this load before is never invoked. So it seems to me that this, at least with this version, with this adapter, page list adapter and page list recycle view, it's always caching. So I guess if you really want to get rid of the already cached data, maybe some additional steps are required. But anyhow, this load before in this example is never called, which is, in my opinion, really weird. Since the only reason, in my opinion, of a paging adapter is that the system keeps only a couple of pages in memory, typically one page, and then when the user want to page either forward or backward, the system always requests the data back from the original data source, which so this caching is not really okay in my opinion. Then we have the load after, which is just loading the next page. So this load after, of course, it is invoked nicely. Then we have to create a factory object, factory class. Here I just make within embedded in this class to make this application less cluttered, and which should be extended from the data source.factory. And here it creates some mutable live data object when this factory is initiated, when it is created, and then it calls some post value ds, the data source itself, you see, and then returns this ds. And of course it returns also this embedded mutable live data whenever it was requested. And then we had to create a view model which extends the lifecycle view model class, where we define another two members with really complex live data page list stack exchange item, and then live data page key data source integer stack exchange answers dot item data source. And then here we create first a factory object, this one, and then when having this factory we get the live data, you see here, which we store in our uh, internal data structure. So actually this object is transferred over to here. This is a reference to this object which is residing within the factory object, you see. And then we have some quite cryptic configuration object which is created with a kind of builder, and then we create the live page list, this list here, the live page list. And then this is the m page list which was used here in the main activity, you see, as member of the uh, view model, and this is observing the data. So this architecture is really just a total mess, and the number of classes and objects required here just to accomplish this simple example. And then also let's have a look at the resources. I have created here a very simple layout with two fields, the image view, and in the image view it's very important that the width and the height should be fixed, otherwise it doesn't work properly. And then the text view is just linked next to the image view. And let's check how it runs. Okay. Okay, my first observation was that I never received the same collection of data. I would say that more or less these data are more or less random, and and of course we can page these data, but I cannot page it endlessly. So when we go back to the logcat and see, we can see that load after, so we are loading 3 pages of data. So practically that was this example. So my final conclusion that this example initially seemed okay, but I'm pretty sure that even the author Belal has no clue what he was doing. He just possibly copycatted some of the examples and then he explained it pretending to be an expert in this area. And then definitely if I really want to understand what's going on, I have to learn thoroughly the whole architecture components, including live data and all of these things. And definitely we should be able to elaborate a lot less complex example rather than this one. But anyhow, this is working somehow, but I'm absolutely not convinced that it has any value so far.